Okay, so welcome aboard, everyone. This is sadly the last session for the DB2 stream at this virtual GSE UK conference. Thanks for joining. Thanks for sticking with us. I think it'd be worthwhile. We've got Mark Rader doing a session on DB2 and WLM. It's a 101 session. So hopefully Mark won't tax your brain cells too much, but there's plenty of information in here to pick up. Please do ask questions in the chat. And we'll get answers for you as soon as we can. And don't forget the feedback at the end. Okay, over to you, Mark.
All right, so before I start sharing my presentation, I want to try to finish the answer that I was giving last time before my internet so rudely failed. Talk about no availability, no backup plan. So Andreas had asked a great question about can you force all the changed pages in the with a archive. Let me see if I get it right, because I don't have the little question in front of me. He had two options for a set log command and another option for a archive a log mode quiesce. And the research I was able to do thus far indicates that neither of those will force all changed pages out. Now, in the case of, I want to say it was set log suspend, where you are basically pausing the logging. DB2 will do quiesce of DBP32K writes, which means writes that are in process will complete for 32K pages, so that we don't get inconsistent situations where you're taking stuff off site and then you have only half of a 32K page when you get there. So that was a problem that was encountered years ago. And so those writes will be quiesced. In other words, those writes that are happening will continue to happen and will complete. But the other writes, the other writes will basically stop, but they'll all be captured in the DB2 log. But there's no requirement that any three of those commands actually go through and push the changed pages out in either deferred write or a synchronous write. All of the changes on those changed pages have already been captured in the log. So each one of those three things will make sure that the log buffers are externalized, so all the changes will be in the log buffer. So hopefully that answers the question. And if someone has a follow-on, I'll be happy to take it right now before I dive into WLM. And of course, I didn't open the chat, so I can't see what anybody is saying. So maybe I should go do that. I've discovered after my first session that I can watch the chat.
So I think you've answered Andreas's question.
Okay.
It's a thumbs up, I think. So we're good to go.
Great. Okay, DB2 for zOS 101, DB2 and WLM. I want to start with a performance story. It's completely made up. But we have here, we're going to start with a skilled DB2 professional who is happily administering their DB2 environment. And at some point along the way, there is a unhappy user calling and ruining our poor professional's day by complaining about performance. And so our skilled DB2 professional then is now unhappy, right? And so calls friends and says, can you help me figure this out? I have tuned my subsystem based on best practice. I've been looking at SMF 100 through 102 records very, closely. I've been monitoring vigilantly. That's enough, right? And of course, the friends come in and start looking at the situation, and what they respond is, no, not if your WLM definitions for DB2 and DB2 work, that is the work that comes into DB2, are set incorrectly. Then you potentially have problems even if you work as hard as you can on the DB2 side. So what I want to talk about today is Workload Manager overview. And actually, I think this is where I'm going to spend most of my time. I'm going to talk about WLM and DB2 address spaces briefly. I'm going to spend a little bit of time on WLM and DB2 work, and this by itself could go for at least an hour. So this is an opportunity to be enhanced in a future session potentially. And a few other WLM interactions with DB2 that I'll touch on briefly. So I've got this little icon here that I'm using to represent WLM. So when I don't actually have WLM on the screen, this will, you'll recognize the fact that this is WLM in case you happen to be looking at the screen all by itself. So let's start with how WLM works in general, right? We have our zOS or zOS system running here, and until we get those irritating things like users and applications, everything is lovely and it works brilliantly. And then we'll get some work into the system. We have a variety of kinds of work that come into the system. In fact, that's one of the strengths of the zOS operating system is it'll handle multiple different workload types. And those workload types, as WLM views the world, are broken into these categories, right? And not all of them are what they appear to be. So for example, our DB2 professional cares about the service class STC, which is about the middle of the list. And I don't know if you can see my mouse, but it's right here, right? So that's where the DB2 address spaces will be. And DB2 professionals care about DDF because that's where distributed comes in. The rest of these are about other kinds of work on the system, and do not be confused by DB2. That is really Sysplex workload balancing, which is deprecated. So this list of work is what WLM looks at, and then WLM will then apply service goals, right? So someone, WLM administrator, is going to define goals. And so as the work comes in, the goals are applied to the different kinds of work, and the work will be set into service classes. And the service class determines how the work runs. And by that, I mean, it determines whether or not WLM, gives them additional resources, CPU, storage, tasks, or IO, right? Those are the four things that WLM will control in getting the work to meet its goals. WLM, as part of the service goals, you can also define a report class. All report class does is tell you what was happening. And we'll talk a little bit more about how service classes are different than report classes and why report classes are important. And we also have dynamic workload distribution, which I'm not going to talk about in the DB2 space. Now, because WLM is the priority and resource manager for work in zOS, it's therefore the manager for work that's coming to DB2, and that's why I care about it. So WLM manages DB2 address spaces. It's got the subsystem address spaces. It's got stored procedure address spaces. And the way these address spaces perform will affect DB2 application performance, right? So if WLM isn't taking good care of these, your applications will suffer. WLM also manages DB2 workflow. So it manages address spaces and it manages workflow. So there's work flowing from allied tasks, say kicks or IMS batch and so on, coming into DB2. And there's DB2 distributed, DDF, and stored procedures, whether external or native. And because of the WLM's role, both in DB2 address spaces and in the work that comes into DB2, DB2 professionals should have a basic understanding of WLM, and that will keep them happy. So that's what I'm trying to do. I don't know if we covered this at the beginning, but if you have questions, please ask them as they arise, because the topics tend to build on each other as we go forward. So let's start with the service definition. A service definition is basically everything that's put into a WLM environment, right? You go through and build a service definition. It defines the address spaces. You have policies, different policies. You can have different policies for different kinds of day, different times of day, or say different days of the month. There are classification rules. Everything, all the work coming into the system goes through a classification rule and gets assigned to workloads. And then workloads themselves are broken into service classes, and that's where we define how the work should behave. And then service classes, the contents or the work in service classes can be reported as the entire service class, or as half of or part of a service class, or across service classes. So you can see my report class A covers some of the work in service class 2, and report class B covers other work in service class 2. And there's a little bit of work that isn't covered by report class A or report class B, right? And that stuff only shows up in service class 2. And then service class C crosses over. So this looks, okay, what does this mean? Well, we're going to have a lot of fun talking about these things, right? Only one service policy can be active at any time. And why would I want to have a policy? Well, a different policy. So you might want work to behave differently during month-end processing. Some work, which normally would be medium importance, at month-end, it's low importance. And other work that's normally medium importance at month-end is high importance. So you can do things like that by setting up different service policies. So let's talk a little bit about terminology. We have a service definition, right? And that consists of one or more service policies. So fundamentally, that's everything that your WLM administrator puts into WLM. And you can print it out, by the way, if you want. You don't have to deal with it with TSO ISPF interface, which is the one I'm used to. You can print it out, or not print it, externalize it in a HTML file. A service policy contains several workloads. One service policy active at a time, and that's whether it's a single LPAR or parallel sysplex. If your LPAR is part of a parallel sysplex, there's only one service policy for all the LPARs in that sysplex. A workload is just an arbitrary collection of activities that belong together. You might have a workload called accounts payable. You might have a workload called online access. You might have a workload called new stuff that just got written last week, right? It really is up to you what you call your workload and what you put in there. And workload consists of one or more service classes. So what is a service class? Well, a service class is where we're going to start getting down to the actual definition of what WLM is doing, right? And each service class is going to have at least one period. We'll have a detailed conversation about what periods are in a bit. And each period has one goal. And if you have more than one periods, then all the periods except the last one have to have a duration. That is to say, if I have 3 periods in a service class, I have to specify how long I'm running in the first period before I go to the second period, and how long I'm running in the second period before I go to the third period, and so on. The last one doesn't have a duration. It's just stuff stays there until it's done. So each service class period has a goal. What are goals? Well, there are 5 types of goals. There are system goals, average response time goals, percentile response time goals, and execution velocity goals, which I usually just call velocity goals. And finally, there is a goal called discretionary. I don't know if the word discretionary means the same thing outside of IT on different parts of the world, but discretionary really means you may get service, you may not. Well, you'll get some, but you may not get a lot, right? So eventually someone gets discretionary. So these are the system is at the top and discretionary is at the bottom. The others can get mixed up in the middle, and we'll look at that in some detail. Finally, we have classification rules, and the classification rules are how you assign address spaces and transactions to their service classes. And classification rules fit parallel, if you will, to service policies in this hierarchy, right? So there's a service definition. There are numerous service policies, potentially one or more. Within the service policies, you have several workloads. Within the workloads, you have service classes. Within service classes, you have at least a period and a goal. And if you have more than one period, then you have a duration. And you have classification rules to assign things to service classes, but the classification rules apply across service policies. Okay, so let's look at the concept of service class and classification. So classification is assigning the incoming work to a service class, and then optionally, you can assign it to a report class. The classification you do is based on a wide variety of filters or qualifiers. Sometimes I call them filters, sometimes I call them qualifiers. But there are ways that WLM will see the work that's coming in and decide what it is. For example, a lot of people think about auth ID with Db2 and DDF. So when a DDF transaction comes in, it would be very easy for WLM to see the auth ID and assign it to a service class based on the auth ID, right? Very easy. Many customers have a single auth ID for a whole set of application servers, which means that 90% of the work is coming in on that auth ID. That's not very helpful, but that's just one example. And then a service class is a set or group of related work. You might put KICS, IMS, and DB2 address spaces, that D is really an S, believe it or not, and it will be by the time the PDF gets uploaded, into the same service class. So you might put that into STC high. STC is for started tasks, right? You might put that in high or production high, something like that. You can group them all together. They don't have to have their own service class, but you might want to report on them separately. So you could have a report class for KICS, you could have a report class for IMS, and a report class for DB2, and you might even have a complex IMS environment have several report classes with some of your IMS regions in one and some of them in another, just for reporting, but they would all be running likely in the same service class. A service class can combine goals of different types if you use multiple periods. And a period is a combination of an importance, which we haven't defined yet, and a goal and a duration. And a service class period, right, which is the smallest unit of granularity now is a service class period. That's the target of WLM measurement. That's what WLM is going to keep track of, and that's what WLM is going to try. That's where WLM is focusing to determine, are you meeting the goals you set or not, and where should WLM apply resources or not. So that's the service class period that's going to be the focus of all of this. And just as a reminder, here's our little hierarchy where all these things fit. So I talked about classification rules, and on this picture, they're labeled qualifiers. So again, the subsystems coming in, many of them, they're all coming, or depending on what you have running in your environment, you might not have all of these. But the ones that DB2 people need to care about are STC for the started tasks, right, the DB2 address spaces, and DDF for the work that's coming straight into DB2, well, through TCP/IP, but basically it shows up. It isn't an, I mean, you could say, well, TCP/IP is sitting there, so it is on the same system, and that's true. But basically, TCP/IP is just handing it off. So as work comes in, you can use these qualifiers, right? Not all of the qualifiers apply to all of the subsystem types, but most of these can be used to qualify DDF work. Once the work has had qualifiers applied, and we've identified, okay, this is how this, this is what this particular thing should be done with, we look at the service goal, which is set up based on the qualifiers, right? So for a particular, once you've qualified work, auth ID, RAD asterisk, for example, then Raider and everybody else starting with RAD is going to show up this way. Then that work will head off and execute under control of that service class and potentially be reported on separately. So WLM assigns the work based on qualifiers, and it only has qualifiers available that apply to the particular subsystem from which the work arrived. So DDF qualifiers apply to DDF, STC qualifiers apply to STC, and so on. Now, we had a long list of subsystems over there. They're not all the same. Some of the subsystem types are address space oriented. Some of them, some of the transaction types are enclave oriented, and some of the transaction types are KICS or IMS. They are special. So if you have address space oriented transactions, You can use response time, execution velocity, or discretionary goals, and you can have multiple periods. If you have enclaves, you can have response time, velocity, or discretionary goals, and you can have multiple periods. And if you have KICS or MS transactions and you're managing by the transaction, then the only option you have is response time goal, and you can only have one period. For the DB2 address spaces, we want execution velocity, right? We want velocity goals applied to the DB2 address spaces. We'll get into that a little bit more. And for DDF, depending on your environment and what you're trying to accomplish, you could use response time or execution velocity or discretionary goals. All right, I should probably pause and see before I go into goal types. Do we have any questions yet? I forgot to open the chat. Oh, there seems to be quite a few questions.
No, it's okay. There's comments, but no questions yet.
Oh, okay, good, super. Okay, so let's talk about goal types. So I mentioned that we had system goals, and those are system and sysstc. And these have fixed dispatch priorities that are above importance 1, and we'll get a picture of importance 1, so please hold on. Things that are up there are like the master, right? The not the DB2 master address space, but the master task that runs the system. Things like the dispatcher. In sysstc, we'll have really important but low I/O kinds of things like the IRLM, right? Some of your monitors will be up in here. TCP/IP will be up there. Those sorts of things. Then we have response time goals. One kind of response time goal is an average response time goal. And basically we just get the response. So let's say we have 10 transactions come in and we're doing average response time goal. If we set a goal that the average is 1 second and all 10 of them come in and they range from 0.9 seconds to 1.1 seconds and the average is exactly 1, then we're fine. But if we have 10 transactions come in with an average response time goal of 1 second, and 9 of them complete in around 1 second, and the 10th one completes in 10 seconds, we're going to miss the goal because we're above the average, right? So the other kind of, we'll get the other kind of goal is a percentile response time goal. So now with a percentile response time goal, that one outlier that took 10 seconds won't make you miss the goal, right? So percentile response time is better for heterogeneous type transactions that belong together, whereas average response time is better for homogeneous type transactions where they're all very similar to each other in their behavior. Execution velocity goals, and I'll mostly just call those velocity goals, those are intended for work either where response time goals aren't appropriate or well, no, for response where response time goals are not appropriate, either where they are address spaces or something like a long-running job, right? If I have a batch job that's going to run for 3 hours, I can't measure response time for a 3-hour job, right? So, and address spaces definitely don't behave like response time, right? How do you, I want my DB2 subsystem up for days, weeks, months. How do I measure response time for that? So that's where we get into velocity goals. And then finally, there's discretionary, and discretionary is for low priority, long running work. And in general, it's probably not appropriate for DB2 work in general. Okay, a little more detail. On execution velocity goals, what this means is how fast work should run in the system when the work is ready to run and it isn't being delayed by something else. So if it was waiting on IO or it's waiting to be dispatched or anything like that, that doesn't count. But once it's ready to run, right, it's ready to take off, how often is it actually running, right? And we express this in a number. Usually you use nice round numbers that are multiples of 10. And a number of 60 means that this service class with a velocity goal of 60% of the time when it's ready to run, it is running. And then 40% of the time when it's ready to run, it's not running. And mostly velocity works backwards, right? That is, WLM is measuring how it's going and calculating its velocity, and then compares that to what you set, right? So it isn't like you turn a crank, right? It's not like Spinal Tap where you say, oh, this goes up to 10 or maybe 11, right? Before it starts running. It's as WLM measures what's happening, then it can see whether or not it's meeting the target you set. It's best to differentiate velocity goals within an importance level. We'll talk about what that means a little bit later, by 10. In other words, if I have a set of work in importance 1, and I want to distinguish between 2 different service classes in importance 1, I don't make one velocity 60 and the other one velocity 59. Right, that's not enough granularity for WLM to be able to manage. So we keep them, we like to separate them by 10. And the appropriate velocity goals can depend on the number of engines you have. The more engines you have, the higher likelihood that you can be running more of the time. So a higher velocity goal is possible. If you only have 2 engines, you're not going to meet a velocity goal of 90, right? Eventually someone else is going to be using the engine and they're going to keep their time slice long enough that you won't make 90. So if you're changing your hardware configuration, you may have to adjust your velocity goals. Response time goals, again, an average of response time, and this is just lays out the example that I talked through. If sorry, you didn't want to hear that sneeze. If you have a response time, an average goal, response time goal of 1 second, and one of them takes 10 seconds, you'll miss the goal. And the percentile allows you to have outliers and not miss a goal. And that's important because you don't want WLM trying to adjust work if there's 1 or 2 outliers. Okay, I've been talking about importance. What is it? So let's look at this diagram where system and sysstc are at the top. And then I've got 5 different levels of importance. And of course, being IBM, we start counting at the bottom. So importance 1 is the highest and importance 5 is the lowest. And so for most work, that's what we're limited to, right? Most of the work is going to be defined between importance 5 and importance 1. WLM is going to apply resources to importance 1 first. If all the work in importance 1 is meeting its goals, then WLM will look at importance 2. And if all of 1 and 2 are meeting their goals, then it'll look at importance 3 and so on. So someone laboring in importance 5 may not get a lot of attention from WLM, and that's the whole idea, right? An important but not time critical batch job can run happily in importance 4 or 5 and eventually get some service and eventually complete. Some service does trickle down to discretionary, even in a busy system. As I mentioned, system and sysstc are internal service classes. They're for system tasks, and they have the highest dispatching parties. Anyone who's been around long enough to remember what MVS performance was like before Workload Manager, we're talking about priority 255 and 254. Finally, at the bottom, we have this thing called sysother. Sysother is the default service class for any work that isn't classified. And then it shows up there and it'll run as discretionary. Now, early on in the days of WLM, there were shops that looked at the incoming work and decided that the label Db2, which I told you meant sysplex query parallelism, actually meant Db2. And so they put a lot of work into defining, the characteristics of the Db2, stuff in WLM, which means the Db2 address spaces got default, settings based on other address spaces, and the DDF work never got defined. So all the DDF work ended up in sysother and performed extremely poorly until someone figured out what the problem was. We'd rather not have work in sysother. You want to know what's in your system and put it into an appropriate importance. But if someone's going to show up without letting you know that they're coming, okay, they can be in sysother. One important fact, and I'm sorry to use the word important here, a vital fact, is not all work can be most important. We have an expression here in the US that you can't put 10 pounds of stuff into a 5-pound bag. So it's like saying you can't put 3 kilos of stuff in a 1 kilo bag, right? It's not going to fit. And one of the challenges in setting up WLM is coming up with realistic comparison of different application workloads and who deserves which performance. Now I'm going to apply this to DB2. We're put the IRLMs up in sysstc because of the nature of the IRLM, right? It doesn't do IO, right? It gets messages and it has to process those lock requests very quickly and return quickly. So we want it running as fast as it can. DB2 is doing IO, and IO is better managed in service classes with importance 1 through 5. So in general, I would expect to see production DB2s up in importance 1. And that WLMX, that's the address space that manages, or that at least starts, WLM stored procedure address spaces. So we want all of the DB2 address spaces to be together in the same service class with the same importance and a velocity goal. Now, DB2 sorry, I just said that, non-production DB2s, if they're in the same LPAR or sysplex, could be in importance 2 or 3 or 4, right? I know that people using, the development DB2 system, for them, it's their production DB2, but it probably isn't going to compare in criticality to your business or your organization with your production DB2s. So you put them there relative to other work on the system. And then discretionary work gets service after all the other importance levels, and it's definitely not appropriate for DB2 address spaces. And I don't recommend it for DB2 work. I have had, I'm not going to call it arguments, I've had lively discussions with some customers who like starting DB2 work in discretionary until they find out about it, and then they can appropriately classify it. Okay, let's see what's next. I mean, I think I already told you this, right? There's very little service if CPU is 100% busy. Mostly, this is stuff that we've covered before. It's here for reference when you get the PDF. I'm not going to go read it all again, but it's designed as backup for the previous slide. Now, we're going to assign goal types. And this is an example. I don't want you to go out and do this, right? But this is an example so you get an idea. It could well be that CICS, IMS, or TSO have average response time goals, right? So their transactions complete in less than 0.7 seconds, right? Depending on their nature, right? This or that or the other CICS region may have transactions that are all fairly similar. They would all expect to behave similarly, so an average goal works for them. The DB2 address spaces themselves are going to run an importance 1 with a velocity goal. My example here is execution velocity of 70 in a single period. My production DDF transactions will run in importance 2, right? You don't want DDF running higher than the DB2 address spaces, because you need the DB2 address spaces to do most of the heavy lifting that DDF is taking advantage of. And you can't spawn more DDF transactions if your DDF transactions are higher than the distributed address space, for example, and start doing a lot of work. So in this example, my production DDF transactions are running in a single period. 90% are supposed to complete in half a second. And then for my non-production DDF, I'm doing a subset of this stuff here. So non-production DDF, in this particular example, I've got response time goals in the first period, and either response time or velocity in the second period, and velocity in the last period. So in this particular example, I have non-production DDF that starts in importance 3, 90% of which should complete in half a second. And then if If it still hasn't completed, then it'll go to period 2, and 90% of those should complete in 4 seconds. And if it still hasn't finished, then I'm going to push it down to importance 5 and let it just run, and hopefully it'll achieve a velocity of 40. So that's just an example of how this works. So multiple periods and period switch is something from the old days of MVS and TSO and things like that, right? If you're bouncing through your TSO menu, you expect really rapid response time. But if you're doing an online compile, you don't expect that to complete really quickly. That needs to take a long period of time. So once it gets started, it's going to consume some CPU and be pushed into another period. That's what we're talking about. So in this DB2 example, and what I did was I just used the non-production DDF from the previous page to lay this example out. So this non-DDF works when it starts. It's going to start in period 1. It'll have a duration of 300 service units. It's running at importance 3. So in the grand scheme of importance, it's the third one on the list for WLM to start paying attention to. It has a percentile response time goal that 90% complete in half a second. Any transactions that finish in 300 service units or less, okay, end of conversation. Any that take longer than 300 service units will get pushed into period 2. Anything running in period 2 is going to run a little bit differently, right? It'll run in importance 4, which means it'll get a little bit less attention from WLM. And the expectation is that 90% of them will complete in 4 seconds. And that's 90% of what's left over from period 1, right? So that's 90% of the 10%. So they should complete in 4 seconds. And anything that still hasn't finished, so we're targeting this to be 1%, will be pushed down to period 3, and it'll run at low importance, and WLM will use a velocity goal to manage it. Now, the important thing to note here is that service units is hardware independent. And so that means is if your transaction consumes 1,000 service units on a Z13, it should consume 1,000 service units on a Z14 or Z15 or Z16, and you get the idea, right? There's a service unit coefficient for each of the different processors, and that gets applied, so you don't have to change your duration definitions as you migrate, as you upgrade from one processor family to the next. I've got a quick example here of the ever so friendly and intuitive ISPF interface for WLM. And you can see the things highlighted in white down at the bottom are the exact same definition just on the WLM panel, right? So there's period 1, 2, and 3. There's the durations of 300, 600, importance 3, 4, and 5, and then the 90% in half a second, 90% in 4 seconds, and velocity of 40. So that's how a WLM person would put your desires from the prior page into action, right? They would go through and put it in WLM. Now, WLM is managing delays. That's really what it's doing. It's watching for delays and trying to manage your delays so that you get the goal you're trying to get, either response time goal or velocity goal. And the delays that it can manage are processor goals. That's really about dispatching priority for the work. Non-paging DAS-DIO. So really, are you getting delayed on IOSQ and subchannel and all those other things? You're spending too much time in IO. Storage, so we're talking about access to real storage, so things like paging and swapping. And finally, tasks. And we're talking there about multi-programming level or server address space creation. For example, the WLM address spaces where you run external stored procedures, right? If you've got one of these running a COBOL stored procedure and it's got max TCB set at 40, that means I can run 40 stored procedures in that address space. What if I have 50 or 60 users that are trying to run that same stored procedure? Well, if I don't do anything, 10 or 20 of them are going to have to wait until the ones that are currently executing finish. But what if the ones aren't going to finish in a while and these other ones are important too? Well, then you want to encourage WLM to start another WLM managed stored procedure address space where the other 10 or 20 can run, right? And so that's what this means by managing tasks. You can define your WLM application environments so that WLM will be encouraged or discouraged from adding new tasks to handle more work. WLM cannot manage user delay. right? Like coffee breaks, or network delay. Nothing WLM can do about that. And any resources or delays that aren't, in the 4 over at the right will show up on WLM type reports as UNK for unknown. Now, the next thing worth understanding is the idea of a performance index. A performance index is a way to compare service classes with different goal types, right? And so WLM is basically saying how well is this work doing at meeting its goal, and it's going to do a calculation. And in the case of response time goals, well, obviously it's counting what's happening and it's deciding, how close you are coming to meeting your goal, and then giving you in effect a fraction to represent that. And for velocity, what it really is doing is it's taking using, when it samples and it's find it's using a resource, that's a using sample. And when it finds a resource that isn't being used, right, that's a delay sample. So it's going to take using samples and divide that by the sum of using and delay, right? And that's how it calculates velocity. So if you're using most of the time, you're going to have a high velocity. And your PI, if you're matching your goal, then you'll get a 1. If you're using more than expected, right? If you're using as 90% of the samples, then you'll have a velocity of 90. But if your goal is 70, then what WLM does is it in effect is dividing the goal by the achievement, right? And so if your goal is smaller than what you're achieving, you'll have a PI of less than 1, and that means you're doing better. And if your goal exceeds your achievement, then you're not meeting your goal, and you're going to get a greater than 1 ratio, and that means you're missing your goal. And of course, if PI equals 1, then you're exactly making your goal, and that does happen sometimes. So where would you find this, right? Now, in general, DB2 people aren't going to go looking for this, but when you start, if you're in a performance conversation and someone is talking about, what's DB2's PI, or how is this DB2 workload doing? They start saying PI. You want to understand what it means. And if you want to go find it, you can find it on our RMF workload activity report, right? You should be able to find it in RMF Monitor 3 as well. So here's an example where I have a percentile response time goal that 80% are to complete in 1 second. That's not a very stringent goal. And as you can see, the performance index here is 0.5. That means we're exceeding our goal. And if you go actually look at what's going on for the actual response time, right, in red, that if I move my cursor around right here, the actual response time, 96.5 are finishing in under 1 second. That's excellent. So we're overachieving our goal, and for this work, that's fine. In the grand scheme of things, that may be an issue, and we'll talk about that in a minute. WLM will show you about your distribution of work, right? The response time distribution. When you do a percentile response time goal, it's going to lay out what happened when. And you can see the entries range from the top one, which is less than half the goal, right? So we said the goal was 1 second. This is half of a second. So that's the first bucket where we start putting samples. And then we increase in increments until we get up to over 4 times the goal, right? So this is between 2 and 4 seconds here. This is between 1.5 and 2 seconds, and so on. And this is over 4 seconds. And you'll notice that all of these guys, almost all of these guys, are so close to 0 that they don't measure, right? There's very few things, fractional things, that are in the bucket. Almost everything is in the very first bucket, and that's why we have such a great response time. But notice also, because we're only measuring half the goal, if your goal is too easily achieved, like 80% in 1 second, you won't have a really good idea of how this stuff is laying out. Is it really taking half a second, or is it taking a quarter of a second, right? Because this is the lowest level of granularity you get reported on. It's half the goal. All right, now here's an example of missing the goal, right? This is a different set of work. it's not response time work, right? It's got a velocity goal, but the velocity goal is 60%, and it's only getting 32.6%. So if you divide 60 by 32.6, you get something like 1.8, and so the performance index is 1.8. Now, this particular one is running in importance 3. So once WLM gets down to importance 3, it's going to be encouraged to give more resource to this work so that it can achieve its 60% velocity goal. Okay, in an ideal world, I would have managed to get this animated. But if we start here, what does WLM do? What really does is it measures. It's measuring and measuring and measuring. Getting using samples and delay samples. And every so often, it's going to calculate the goal and compare the goal with what you stated in your policy. And if your performance index is greater than 1, then it's going to give you some attention. What it can do is it can change your priority or access to tasks and storage and IO. But basically, I use priority because it's the easiest one to talk about. So if it wants to increase your dispatching priority, it has to go find someone to take CPU from, right? It has to find a donor. If the workload on the previous page is the one that's going to be the receiver, we have to find a donor. And donors that WLM goes and looks for, donors are ones who have a PI of less than 0.7, right? So they're really doing well. So we're going to take resource from them because they're doing great and give it to someone who isn't doing great. WLM then waits 10 seconds before it sees what reaction this has had. And then it does it again, and then it does it again, and then it does it again. It's important that you set accurate goals to reflect how things really work, and they should be realistic. If the goals are unrealistic, right? I have really complex transactions, but I want them all to complete in 1/10 of a second. We're never going to achieve that goal. WLM will try a few times, then it'll give up. It'll still try again sometime later, but finally I said, that's unachievable. I'm not going to waste my time managing it. Loose goals, the ones that are too easily achieved, can allow for poor performance, right? Most times your system isn't very busy and you're easily achieving those loose goals and you're doing just fine and getting great response time. But when the system gets busy, you're a donor. And all of a sudden the resources that you've been getting used to get applied to others. And you finally are behaving like your goal, right? Which is that 80% complete in 1 second. Well, if I completed 1 second, maybe I'm okay, right? And 80 of us complete in 1 second, okay. But what about the 20 who don't complete in a second, right? They're not going to be happy, and the help desk phone will start ringing. So WLM applies that heuristic on the previous page to service class periods. And WLM can effectively manage 25 to 30 or maybe 35 service class periods, right? Otherwise, the constant checking and going back around and calculating whatnot just becomes burdensome, and WLM can't cycle through them fast enough for everybody to get what they want. And it really gets to be a problem when the system gets busy. And that's when the system is busy, that's precisely when you want WLM to make adjustments for you so you can meet your goals. So loose goals, and this is just, the stuff I said on the previous page. You don't want to be a donor. You don't want to be loose. You want to have accurate goals. Okay, WLM and Db2. Before I go on, anyone have a question at this point on the WLM overview? That's where I had intended to spend a lot of time because not a lot of Db2 professionals are easily conversant with that, in my experience. Okay.
Yeah, there's no questions at the moment, Mark.
Thank you. So Db2 address spaces get defined in WLM. They're started tasks. So from WLM's point of view, they show up in the subsystem type STC. IRLM should be in sysstc, as the example I showed you before. The rest of the Db2 address spaces should be assigned to a service class with a single period and a velocity goal and an appropriate importance. So for appropriate, that means, higher than the work that's being done, right? So DDF work would be an importance 2 and production importance 1. Or if you have really super important stuff in importance 1, production in importance 2, and DDF in importance 3. Similar things happen with kicks, right? You can't have the kicks transactions have higher goals than the KICS regions, because the KICS regions have to be running for the transactions to do anything. And then QA, develop, or test, if they're in the same LPAR sysplex, will be some importance greater than 1, i.e. a lower importance. And then, of course, the argument then becomes, is QA work more important than production batch or not, right? I can't answer that. And what I'm talking about for these DB2 address spaces is master, DB1 DIST, and the WLM stored procedure address spaces. Okay, that was quick. We're done with the address spaces. They're in the right place. IRLM is in sysSDC. Oh, by the way, when we do health checks, we still find people who don't have IRLM in sysSDC, or who do have DB2 system address spaces in sysSDC. Quite some time ago, there was some disagreement about whether or not master or DBM1 should be in sysSDC, but the fact is that they both do so much I/O, they need to be in an importance, not in sysSDC. Okay, WLM and DB2 work. There are 3 types of DB2 work that WLM is going to pay attention to. There's local subsystem work, right? These are allied threads, KICS, IMS, TSO, WebSphere on Z, on Z systems, MQ on Z systems, right? The kind of work that's sitting here on the same LPAR and is coming into DB2. There's DDF threads, right? And DDF threads are enclave SRBs, which we'll get into a little bit, and are typically eligible to run on a zip. And there are stored procedures. There are 2 kinds of stored procedures. There are external stored procedures. These run in WLM managed stored procedure address spaces, which are defined with application environments, which is basically the JCL to run them. And there are native SQL procedures, and these run in the DB1 address space. So each of these kinds of work is going to get managed by WLM. So for the allied threads, right, that are using a local attach, in my example here, I've got KICS and IMS. These things have already gone through WLM qualification before they get to DB2, right? The workload coming into KICS or IMS, and the KICS and IMS address spaces themselves, right, have gone through the assignment of service classes before ever getting to DB2. So we don't worry about it anymore. We use the same service class that was already defined. So the conversation is over, right? Whatever happened there, they have a dispatching priority, and that's what they get when they come into DB2. And then, of course, from WLM's point of view, the work that gets done in DB2 gets sent back to the invokers. So, KICS activity in DB2, yes, we can report on it in accounting reports, but it'll show up in the KICS measurements for WLM. All right, the second kind of work is DDF. And DDF is an interesting critter, right? So here we have, ideally this would be animated. Didn't get to make it work correctly, so I just got rid of the animation. The DIST address space here is running with the DB2 address spaces in sysSTC. And you can see down here at the bottom, right? The address space itself is running according to STC rules. In my case, I have STC high as the service class, along with the other DB2 address spaces. It's got a velocity of 70 and an importance of 1. And we're going to produce SMF 72, right? What's one of the RMF records, and SMF 30 to track what the dist address space is doing. Now, the work that comes in to distributed, it's going to come in as DDF requests. And if they're DDF requests that have a certain degree of priority, they're going to get assigned to one service class. And in that case, it's DDF pri for priority. And I'm giving them a response to a 90% response time goal to complete in half a second and run in importance 2. And then default DDF requests are going to get their own, assigned to their own service class. They have different rules. They're going to come under DDF default. And in my situation here, I have a response time goal. It's an average response time goal. They need to complete on average in 5 seconds, and they're going to run at importance 3. Each of the different service classes will get an SMF 72 record that you can report in the RMF workload activity report, so you can see what's going on. Now, what is an enclave and why do we need enclaves? So an enclave is, and there were a whole bunch of pages that we could spend a lot of time with those. An enclave is a separate way to manage dispatching party and account for work, right? In the original MVS, you just accounted for work based on the address space. But we can have lots of different work running in DIST, and we have to be able to differentiate it. So that's why we need enclaves. We're going to manage DDF work separately from the address space where it's running, and we're going to differentiate between high priority, medium priority, and low priority DDF work. So when it comes to classifying the DDF work, you're going to have to define a service class with appropriate goals. You have to make sure you set up a default so it doesn't end up in sysother. And then if a new DDF piece of work comes in and it doesn't have qualification rules, it goes to the default DDF service class, not to sysother. Right. And then for managing those enclaves, you can use any of the goal types, right? If you have multiple period goals, then they might be subject to period switch, like the example we went through earlier. And WLM will manage the enclave with its own dispatching party as it runs. And again, production DDF work should be below that of DB2. So what does this DDF transaction look like? Well, it looks like most of the time, if commit status is equal to inactive, which most of you have, the DRDA unit of work is happening, and we're going to queue and wait till we get a DBAT. We're going to execute. We're going to issue a commit, at which time we're going to disassociate the connection from the thread. The thread will be idle, and then when we reconnect and start running again, we get queue time and execution time. So each of these two parts here, part 1 and part 2, are going to be active threads, and they'll be enclaves managed by the system resource manager individually. If I have commit stat equals active, or if I have high performance DBATs, then the database thread is active from the time it's created until it gets terminated. So this is going to look like what you might think of as conversational, right? You pick up the phone and you talk to someone for a long time. You go back and forth, you look out the window, you're still on the phone, right? It's a very long thing, a long unit of work. And so we have to handle our normal DDF transactions differently than we handle our high performance DBAT transactions. These we can use, response time goals, right? Whether either percentile response time or regular response time goals, or we can use velocity, especially if you have multiple periods. But for these, you pretty much have to use execution velocity. And there was a recent change, I didn't get the PTF on here, that changed how we handle high performance DBATs and their termination. And it means that they're going to behave, from WLM's point of view, they're going to behave like one really long transaction, and WLM won't know how many times it actually got invoked. DB2 will tell it later, but it's not quite the same as WLM knowing, because right here, WLM knows exactly what's happening, right? And so for these, you really need to set velocity goals for high performance DBATs. Okay, I have a brief conversation about other WLM interaction with DB2. Autonomic buffer pools. If you do an alter buffer pool to say, and now I forget the name of it. Oh goodness. Anyway, there's a setting that you change on the alter buffer pool command that for some reason is escaping me right now, that allows WLM to manage the size of the buffer pools, right? And if you have set that to yes, then you also get to set min size and max size to give WLM the range, and then WLM will increase or decrease the size of the buffer pools. I personally only know of 2 customers that are doing this. So if any of you are doing this, I would love for you to let me know either in the chat or separately. The other thing where WLM gets involved for DB2 is sysplex workload balancing. And that's where you're in a parallel sysplex, and your clients, so your JDBC or ODBC clients, can specify that they want to take advantage of Sysplex, meaning that they can run a period of time on this DB2, and then if another DB2 looks like it's giving better performance, they can go run over there, then they can get back. Or if one DB2, fails or they lose the connection, they can go attach to the other one. And WLM is providing input to DB2, and DB2 is providing a weighted list back to the clients to say, here are all the DB2s, this are the ones that are happy, here's one that's not happy. And then, so that's WLM providing input to that list. And then finally, I just have to mention zip and IIP on a priority. This is a setting in WLM to decide whether or not zips, if they're busy, will ask the general purpose processors for help. And it's an arcane subject that needs a lot of discussion. We could probably spend about 20 minutes on it. But fundamentally, it's important for DB2. Actually, it's really important for DB2 that I spell honor priority with an R right here. So I'll fix that. But the other thing is that your WLM people don't set honor priority no for the system. Because if DB2 sees that IIP honor priority is set to no, then DB2 will not send the system tasks in DBM1 and master to zips. And you really want those things to go to zips. You want the service tasks, you want deferred write, all of those things to go to zips. And so you really want IIP honor priority set to yes for the system. You can set IIP honor priority to no for individual workloads, like if you're doing Spark, right? You're doing a bunch of AI, and it's going to be chugging along. You want that to run on a zip. You don't want it running on a general purpose CP. So for that particular workload, you would say IIP honor priority no, and for the system, you would say yes. That way, DB2 will send the work that it wants to send to the zips. Okay, there's plenty of things we could keep going. I've run over by a bit. Please fill out your evaluations. Let Colin and Marcus and the rest of the team know if you want to know more stuff about more of these details, or if you just want to see this again with the animation fully in place. And I very much want to see what the feedback is. And thank you very much for attending. I don't see any questions in the chat.
No, I can't see any other questions, Mark.
So I'm guessing it's the last session of the conference. People are eager to move on to the next activity, which for them could well be an appropriate beverage at the local establishment. But for me, it's more work.
Same with me. Well, thanks, everyone. That's the last session for the DB2 stream. And the session is 2Q. Please do follow the link there and provide your feedback. We need that to improve going forward, as always. So as I say, that's the last DB2 session, but there is one more keynote session today, and that starts at 5 o'clock. And it's an interesting one from a guy from Data Kinetics called Larry Strickland. So, and it's entitled, "Is the Grass Really Greener?" We know Marcus says it is in Wales, but we'll have to see whether it is with Data Kinetics. So that's at 5. Got a bit of a break before then. And thanks very much indeed for following the DB2 stream. Catch you again soon.